Hello friends, welcome you all in the video leftmost derivation and rightmost derivation. During the parsing process, we require to our compiler or syntax analyzer phase of the compiler required to obtain the given input string by using the production rule. So during this parsing process, the production rules are replaced with the given set of non-terminals and production rules. So based upon the sequence in which it is going to replace the productions or the non-terminals in the given production rule, the derivations are classified into two major types. One is called leftmost order of derivation, and second one it is called as rightmost order of derivation. So in the leftmost order of derivation, we have seen that already in the previous video. We have seen, so in the leftmost order of derivation, the input is scanned and replaced with the production rule from left to right. So input is scanned and it is replaced by the production rules from left to right. So in the leftmost order of derivation, we read the input string from left to right. So we read the input string from left to right. So that particular order of derivation, it is called as leftmost order of derivation. Now we have discussed the example also. Suppose the production rules are given s equal to s plus s, and then s can be replaced by s minus s, and s can be replaced by non-terminals a, b and c. So if the input string is given a equal to a minus b plus c, so if the leftmost order of derivation is followed, then that will take the form like s equal to s plus a. So s plus s, if this is the expression, and if we combine it in the left and rightmost order of derivation, so in this particular case, so s, it is in the left hand side and this s is in the right hand side. So we are now replacing this s first from the left hand side. That's why this particular order of derivation, in which we are going to select the leftmost symbol first from the given expression, so that particular expression, it is called as leftmost order of derivation. So we have selected this particular symbol, so that can be replaced by this s minus s, and then in order to derive the input string, so we are now started replacing now in this way. So s equal to a minus s plus s, then s equal to a minus b. Now then we have replaced with s equal to s a minus b plus c. So in this way, the order of derivation, first we have started with the leftmost part of the given input string. That's why it is called as leftmost order of derivation. Now we are going to start with the second type of derivation, that is called as rightmost order of derivation. So in the rightmost order of derivation, the input is scanned and replaced with the production from right to left. From right to left, the input is scanned and it is replaced with the production from right to left. That's why it is called as rightmost order of derivation. So in the rightmost order of derivation, we read the input string from right to left. For example, if we are having the input string a minus b plus c, and we are having production rules like s equal to s minus s. So s equal to s minus s. So we are starting with the rightmost symbol in the given production rule. So we are having this s in the left side and this in the right hand side. So we have started replacing this one with the production rules. So s equal to s minus s, so s minus s plus s. So we have started with this rightmost input symbol. So that's why we have replaced this one with s. Then now we are going to derive the input string a minus b plus c. So here we have first replaced this s with the c and then remaining symbols like B and A we are going to replace one by one, starting from right to the left. So we have started with the production rule like this: s equal to s minus s. Then we have selected the input string, and based on the production rules we have started with the right hand side of the production rule. So we have replaced s like this. So now we are having the production rule, so that's why we have replaced it by first by C, because the input string is a minus b plus c. We are going to obtain the input string. So for obtaining this input string we are going to replace this by taking the rightmost order of derivation first. So rightmost symbol, that is s. So now s equal to, we have replaced, and with the input string given is s a minus b plus c. So we have replaced this one with c, and then with b, and then with e. So in this way we have replaced the entire production with the starting from the right symbol or rightmost order of derivation. Starting from right hand side we are proceeding to the left hand side. So we have obtained the input string s equal to a minus b plus c by using the rightmost order of derivation. So this same process can be used in the compiler syntax analyzer phase for obtaining whether, or for checking whether the particular set of tokens generated by the lexical analyzer it is correct as per the syntax of the given programming language. So for that, in the context-free grammar and formal languages, we have to draw the input string from the given set of grammar rules. So in that we require to use some derivations. So for particular derivation process we are having the choice, either we can go for rightmost and leftmost order of derivation. So in this way we are having this rightmost and leftmost order of derivation. Now coming to the next terminology which we are going to discuss in the our formal grammar, like parse tree. So parse tree, what is parse tree? So we are going to discuss regarding different definitions of the parse tree, and based on that different definitions we are going to try to understand what is the meaning of parse tree. Okay, now what is parse tree? So parse tree is a graphical representation of symbols. Symbols can be terminal and non-terminals. So parse tree is a graphical representation of symbol. Symbols can be terminal or non-terminal. So it is a graphical representation. Basically a parse tree is nothing but it is a graphical representation of symbols. Symbols can be terminal and non-terminals. So in parsing, string is derived using the start symbol. Root of the parse tree is the start symbol. So root of the parse tree is the starting symbol. It is graphical representation of symbols that can be terminal or non-terminal. So basically a parse tree is a graphical representation that can be terminal and non-terminals. So that symbols may be terminals and that symbols can be non-terminals also. Parse tree follows the precedence of operators. The deepest subtree traverses first, so the operator is in the parent node has less precedence over the operator in the subtree. So parse tree follows basically precedence of operator or hierarchy of operator rules for particular representation of the input string. Deepest subtree traverse first. So for finding what is the whether that parse tree it leads to the input string or not, so we are going to find out we are going to traverse or visit first the deepest subtree, then the operator in the parent node based on that precedence over the operator in the subtree. So basically a parse tree is nothing but it is a graphical representation of symbols. Symbols can be either terminal or non-terminals. And in the parsing is derived using the start symbol. The root of the parse tree is the start symbol. The graphical representation symbol that can be terminal and non-terminals. Now the parse tree follows points like the leaf nodes have to be terminal. The leaf nodes have to be terminal. The integer nodes must be non-terminals. In order to traverse given original input string. So if you want to find out whether that parse tree it is going to be whether that parse tree it derives the input string. So the when we are going to construct the parse tree, then all the leaf nodes have to be terminals, all integer nodes have to be non-terminals, and in order traversal if we perform on the parse tree, so in order traversal if we perform on the parse tree, so it will give the original input string. So it will give the original input string. So in this way the parse tree has to follow certain rules. Based on that rule we are going to find out whether that parse tree represents the grammar or not. So parse tree is a graphical representation of symbols. That symbols can be terminal and non-terminals. In parsing, string is derived using the start symbol. The root of the parse tree is the start symbol. All leaf nodes must be terminals. Interior nodes must be non-terminal. If we perform in order traversal of the parse tree, so it should generate the input string. So these are the some points which must be considered while we are going to construct the parse tree. Basically parse tree is the representation which is used in the syntax analyzer of the compiler phase. So input to the syntax analyzer is the set of tokens, and the output from the syntax analyzer is the parse tree. So basically the aim of the parse tree is to check whether the set of tokens generated by the lexical analyzer it is correct as per the syntax of the language. So for that this particular parse tree use context free grammar, and by using production rules we are going to generate the parse tree, and that parse tree will decide whether that particular set of tokens generated by the lexical analyzer they are correct as per the syntax of the given language or not. So in our next video we are going to discuss regarding the example based on the parse tree, how to construct the parse tree, what are different notations and examples that can be used in the construction process, how to replace the production rules, and what will be the conventions that can be followed during the construction process of the parse tree. So here in our video we have discussed regarding the order of derivation, rightmost and leftmost, And then we have discussed regarding the parse tree. In the next video we are going to discuss some examples based on the parse tree, how to draw the parse tree for given set of production rules. Thank you.